So let's talk about here displacement and distance again. So we have seen, what if we walked 4 meters, let's say to the right, or you could say to the east or whatever, and then we walked another 3 meters to the east. What would be our distance and our displacement? So I'll just write distance as dis here. So our distance is 7 meters that we walked all together. And our displacement, I'll just write as delta x, is also 7 meters in this case. We're 7 meters to the right of where we began. What if we walked 4 meters to the east, let's say, or right, whatever, and we walked 3 meters to the left in this case? So we've already done this. Our distance that we walked would be 7 meters again, 4 this way, 3 that way. And our displacement, though, in this case would only be 1 meter. We're 1 meter away from where we began. But what if we walked 4 meters, and I'm going to make it a little bit bigger here so you can see it a little bit more easily. What if we walked 4 meters to the east, let's say, or right, and then we walked 3 meters to the north or up or whatever? What would be our displacement then? Well, the same rule still applies, that displacement is the distance from our starting point to our ending point. So this represents our displacement. Now we can see that our distance is still 7 meters. We still walked a total of 7 meters. But what is this distance right here? Well, you may already see what's coming here. We need a little bit of geometry. So Pythagoras said that a squared plus b squared equals c squared. In other words, this side squared plus this side squared equals this side squared. And so if I take 4 squared is 16 plus 3 squared is 9, 16 plus 9 is 25. But then we got to take the square root of that side, square root of 25, and so 5 meters there winds up being that side. It's a 3, 4, 5 triangle. So our displacement in this case, all right, delta x is equal to 5 meters. We walked 7 meters, but we're 5 meters away from where we are. So one thing is these arrows that I've drawn, we've seen this term vectors before. So, but the arrows themselves we also call vectors, and they can represent any of the vectors that we've talked about. Here, they're representing displacements, but they could also represent velocities. So you could be on a boat that's going 4 meters per second this way, and you're walking 3 meters per second that way. Then the overall velocity would be 5 meters per second that way. They could be accelerations, although you never really see that in the problems we're going to do. And something we haven't encountered yet, but will, forces. So it could be any of those things, because those things are all vectors there. So another way that you could do this, another example, is you could have, let's just say, and it doesn't have to be nice, east and west and north and south here. You could walk 10 meters this way, whatever that is, and then you could walk, let's say, 10 meters this way. And then to find the overall displacement, you would use the same technique. If you started here and you wound up here, that would represent the displacement. And we would do the same thing. We'd use the Pythagorean theorem. So 10 squared plus 10 squared, take the square root of that to get this side, and you get about, rounding off here, 14.4 meters in that case. Let me show you one more type of example, and then you'll be ready for the first worksheet here. So let me get this one out of the way so I have a bit more room. What if we do a series of steps here? So let's say you're making some turns through the hallway, and let's say you walk 6 meters, let's say to the east, and then let's say your next step is you walk 10 meters north, and then let's say you go 8 meters to the east after that, and then let's say you go 5 meters south. And one way we could differentiate between north and south is by putting a negative in front of it. And then let's say you go 2 meters to the west. And again, if I'm gonna call east positive, then I better call west negative. So how are we gonna find your total displacement in this case? So if you have a bunch of different little steps here, the first thing you wanna do is add up all your east-west and then add up all your north-south. So let's add up all of our east-west. I might sometimes see this symbol right here on the coming worksheets. So that just means sum. It's the Greek letter sigma, it's an S for sum. And so all the east-west here, well, I have 6 plus 8 minus 2. So that gives me a total in that case of 12. So 12 positive, so overall to the east there. Now let's do the same thing with our north-souths. Let's sum up our north and south lines here. Well, I have 10 north minus 5 south down there. And so I have a total of 5 meters north. Now that we have our total east-west and our total north-south, we can draw a new triangle that just focuses on these two numbers. So all together, we want 12 meters to the east. And all together, we want 5 meters to the north. And now do you see, we're back to having a nice right triangle that we can use the Pythagorean theorem with. So 12 squared plus 5 squared will give us the square root to this side right here. And it turns out if you do 12 squared plus 5 squared, that's 144 plus 25 gives you 169. And then take the square root of that and you get 13 meters is the overall displacement. So your first worksheet here, the questions look something like this, and they're pretty straightforward. So first time is you've got Dexter as a Boy Scout and he's walking these different distances here. Don't worry about these directions. These directions don't matter on this worksheet. What you only need to focus on is he walks 50 meters this direction and then 20 meters this direction. So use the Pythagorean theorem. That should be pretty easy to find that overall distance here. And then on another one, I can't remember which one comes first. Oh, that's A, yeah, so, and then this must be B. 60 meters in this direction and then 20 meters in that direction. So use the Pythagorean theorem to find the overall displacement there. And then the last part of this worksheet looks like this. So students A and student B take all these different turns through the hallways. And look at this, north, south, south, and then here east, west, west. So the very first thing you need to do is just like we did on the example, is sum up all the east-wests. Count east as positive, west as negative, and get the sum there. And then sum up all the north-souths. Count north as positive and souths as negative. And once you get your final, and I don't know if the total is north or south or east or west, but once you get your total east again and your total north, let's just say you had a total east and a total north, then you put those two together to make a new sides of your right triangle, and your overall displacement right here will be the hypotenuse, it's called, remember, of that triangle. So you'll use Pythagorean theorem to get that.